Hello, my name is Christopher Skack, and I'm here today to show you some of our new features on our 70,000 series AWG products. Here at Tektronix, our product teams are always striving to design new and improved products, but we also try to improve the products that we have existing today to help continue to solve your complex application requirements. So the new features that I'll be showing you today are now available on Tektronix.com as a free upgrade for our 70,000 series AWG products. Here we see the new features available with this 3.x version of firmware just released. The last one is new hardware, but this hardware is enabled through the new firmware. I will now walk through each of these features except for the last one. The synchronization hub enables easy synchronization up to 4 AWGs, and this will be covered in a separate video. So let's start with the internal trigger support. This flexible internal trigger capability allows the user to select a repetition rate of the internal trigger from 1 microseconds to 10 seconds. This dialog is available in the trigger setup menu, as I'll show you in a second. This gives the user the ability to slow down the internal trigger such that other devices can be ready when the trigger fires and enables the playing of a waveform. So you find the setup for the triggers in the setup menu under trigger, and you can see now that we have an interval capability, and we can set this interval, as I said, up to 10 seconds, allowing the user complete access to the internal trigger. The next capability is what we call fast B trigger mode, and this is available on the 2-channel AWG series. And this allows the user the capability of fast trigger on both A and B trigger. Previously, we only had fast trigger on just the A trigger. So now, depending on your application, you have the capability of getting fast trigger to output, waveform output, as fast as possible that the AWG can accomplish. As we see on the actual AWG screen, we have the capability of now selecting either a fast trigger or slow trigger in both A and B trigger mode on the 2-channel AWG series. So we've also added the capability of allowing users to edit and create generic waveforms. So having a waveform creation tool built right into the instruments allows the user to build basic waveforms without requiring external software to do it. As you can see, it allows the user to build specific waveforms to their requirements. So here we see to select the waveform tab, and then we have the capability of selecting a specific type of waveform that we want to use. So we can create a sine wave, square wave, triangle wave, ramp, noise, or DC. And then we have all of the requirements depending on the specific application that you're trying to do on the requirements for that particular application. So you can set these within the application. Once you set your criteria, you can also define what the waveform name will be. You can override existing waveforms and have it automatically send the waveform to the channel. And then you hit the compile button and it creates that waveform that you just created. And you can see from my compile settings that this was the particular name that was associated with this. So now we have the waveform. If we go back to home, we can drag that waveform into the display, and you can see that this is the sine wave that I've just created. So here we see the slide for modifying waveform and markers. By right-clicking on a waveform in the waveform list, we have the ability to modify the waveform. And this gives us the capability of resampling, adding or subtracting samples, repeating waveforms, multiplying waveforms, or rotate and shift the waveforms. And we can also insert a pattern of either a high, low, or a pulse. So in the AWG user interface, if you right-click your mouse on the waveform in the waveform list, we have what's now called Modify Waveform. And if we go into this dialog, we can either open the waveform editor that we just saw, or we can actually edit the waveform with a specific criteria that we've described. So if I go into this criteria, you can see that in this case we can resample the waveform depending on specifics that you give the dialog here. Now we can also go in and rescale the waveform, so this gives you the ability to increase or decrease the waveform amplitude. We can rotate and shift the waveform. This allows the ability to shift the waveform in phase such that you can move the waveform to align with specific patterns that you're using. So we also have the capability of inserting patterns within the waveform. This is typically used with markers, and in this case what we can do is we can define an area using the cursors within this display, and then you can define what you want the pattern to be, either a high or a low or a pulse. So in this case, let's say we set it for high, then we go in and compile the waveform. You can see now that the high of the marker 1 and marker 2 are between the cursors, and then it's low for the rest of the waveform. Our next feature is the ability to load multiple waveforms rather than just individual waveforms from a single directory of the same waveform type. So this gives the user the capability of inserting multiple waveforms into the waveform list rather than doing one at a time. From the interface, you can see that if we go in and select the Load Waveform in the Waveform List tab, we can select the directory that we want to get the waveforms from, and then we can do a selection by selecting one of the waveforms and then doing a shift and selecting the rest of the waveforms. So all of these waveforms now will be opened into the waveform list as you see here. So our next feature is what we call an Excel sequence import or batch compile feature. This allows the user to create an Excel file that has specifics of a sequence in it to generate and create generic waveforms within an Excel document rather than having to do it within the AWG application. So this allows the user to create specific Excel spreadsheet that sets up the instrument the way they want to in this spreadsheet, and then import that into the AWG and have it set up the sequencer with the criteria in the sequence. To use this feature, basically we go in and open the CSV file as we select the main open here in the top toolbox of the AWG interface. So as we see here, we can specify this .csv file, so I'll select that, and now it's opened it, and I can drag that into the home display, and you can see my sequence now in that display. So that was all open from that Excel spreadsheet. If you need to edit the sequence, you can right click and modify the sequence, and this will take you into the editor, the sequence editor, and allow you to make modifications to that particular sequence. But as you can see here, it followed the spreadsheet that we just were looking at with all the waveforms, the repeats, the event jumps, and all the criteria associated with that Excel spreadsheet. The next feature is what we call sequencer flags, and as I mentioned before, this is an LVDS signal output on the rear end of the instrument. There are 4 flags per channel, so if you have a dual channel box, you'll have 8 flag outputs. These flags are associated with the sequence specifically, and allows the user to set a flag such that when a sequence step starts, it can either go high, go low, toggle between high and low or whatever the previous state was, or create a pulse out the output of the designated flag that you have defined in the sequence. The sequence allows you to put up to 4 flags per sequence step. So you can have a different output for each flag. So this is very useful if you need to know when a particular sequence step has started. It'll allow you to control some other instrumentation. So I'll use the same sequence that we were looking at prior, and you can see that in the sequence itself there is a column for our flags. So with each sequence step we can define the individual flags that we want to set. So as I double click on this entry for my second index flags, you can specify, like I said, up to 4 flags designated by the flag outputs on the rear of the instrument, and we can specify either high, low, toggle, or pulse. So here we see the criteria for the flags. In this case, the sequence flag is initiated with the start of the waveform, as I mentioned. The flag is set to play when the playout begins, so the timing of the waveform and the flag transition is specified in the data sheet. So this gives the user complete flexibility of being able to create a flag and have it play out, again, to allow the user to control other instrumentation. The next feature is what we call subsequencer. Basically, the subsequencer allows the user to have a sequence within a sequence. This can simplify the complexity of a sequence by creating a subsequence that can be used many times within a general sequence. Think of this as being like a subprogram or function in programming. If the user has a specific waveform or a set of waveforms that are repeated frequently in a sequence, it is easier to create a subsequence that can be called many times within that main sequence, rather than having them individually called all within the main sequence. So to use this subsequence, you create a sequence as you would a normal sequence, and then you drag and drop that new sequence in whichever step that you want to use as a subsequence. So here I'm going to drag this sequence of sine, triangle, square into my step 2 of this general sequence that we created earlier. So you can see now there's a little triangle on step 2, and this is the subsequence, and if we double click on that step, you can see the subsequence that we created earlier. So now we have on step 2, it will go in and do a sine with one repeat count, then a triangle, then a square. Now you'll notice that in the subsequence we don't have the capability of using event jumps or any of the trigger features. So within a subsequence you can only go from one step to the next step. You do have the capability of selecting your repeat counts and where you want to go to within the sequence, but you cannot use your trigger events.
Find out more at Vicom's website.